Hello and welcome to episode 14 of Vending Machine Tycoon. Now today I've got a bit of a surprise for you. We're going to take a break from developing the gameplay and developing all these elements that we use that actually contribute to the player playing the game. And I'm going to do something that you don't usually find in a game with this amazing caliber of graphics, which is we're going to add some shader effects. Now I'm going to be developing a custom shader. I don't think it's used in any other isometric game that I'm aware of, although I haven't done any research to back that up. But basically, I'm going to call it the cloud overcast displacement shader. The cloud overcast displacement shader. Now you may be aware of some games where basically you might see some clouds going over the player, a 2D game. For instance, the SNES Harvest Moon. Let me see if I can find an example here. Oh, really? Oh yeah, here we go. There's like a cloud sprite, but this sprite, even in this game, you can see that the shadow doesn't really interact with the isometric layout. The shadow here on the sign, it doesn't actually contort. It doesn't actually bend along with the edge of the sign. It's just a flat image that's overlaid on the screen. And I'm pretty sure this is supposed to be the shadow of the cloud. It's not the cloud itself. We're just looking at a shadow. The cloud is actually somewhere behind the camera. Okay, so back to this game. The angle of this game is a lot steeper. I don't know if steep is the right word, but basically we're mostly looking from the side, not from the top. Whereas in Harvest Moon, it's a lot more of a top-down view that we have here. Alright. Wow, this is some fan art of the... Man, I used to love this game. Spent hours playing this and various other Harvest Moon games from the franchise. Alright, now basically what I want to do here is I want clouds to go over the top, but I want them to bend along with the geometry of the level. So for instance, here we have the side of the vending machine. I don't want the cloud shadow to simply pass over it as it is. Like if it was a full if the cloud shadow was a circle, I don't want it to just pass over. And maybe I can demonstrate that further down the video. But first, let's get into shaders and Cocos 2D JS. So I did some digging around. It's not extremely plainly obvious. There's no online tutorial. I dug around in the tests, and I found some. I found an outdated GitHub page. It was mostly useless because the API had completely changed. So I might actually, what I might do is, in addition to this video, I might go and put up a blog post, just simply letting people know how to implement shaders in Cocos 2D JS, since I couldn't really find that kind of information online. Luckily though, with some preparation for this video, I was able to figure it out. Okay, so first things first, you got your two shaders here. I'm not going to go too deep into what shaders are, what are the different types of shaders. So I expect you to have some knowledge if you want to understand what I'm talking about. If you don't have any knowledge, but you don't care too much, you just want to see the cloud effect, you can probably stick around. And I'll try not to bore you with the specifics. But anyway, here's what we have. Here's what we call the vertex shader. The vertex shader basically takes the position of the vertices. Let's say if we had a 3D cube, each one of these, each one of the joints, the dots, that's a vertex, right? And so basically the vertex shader takes all these and decides their position. Now you might be going, oh, so are these here, are these vertices? No, they're not. No, this is a 2D game and I drew this vending machine on a flat plane. So the only vertices in this game are actually squares. So this vending machine is a square, there's a vertex here, vertex here, vertex here, vertex here. This guy is a square, they're all squares. And the texture is using alpha value so that around it is transparent. That's how you get the shape. Okay, so vertex shader, not too important in terms of a 2D game, because you're mostly going to be working with squares and that shape isn't going to change much. But I'll go back in a sec and I'll show you what we can do with the vertex shader. And this is the pixel shader. And I forgot to mention, these are both GLSL, the OpenGL shader language. Since most cell phones, most smartphones use OpenGL ES 2.0, and so does WebGL. So recently, this, in my opinion, this has taken over as the shader language. Back in the day, we had CG, HLSL is, I think it's still popular on a Direct3D 11. But these GLSL shaders are the only shaders that you'll find in terms of mobile phone games, with the exception of Unity, because Unity uses the CG language. Oh man, I'm going on a major tangent. Right. Back to, okay, this is the pixel shader. Now the pixel shader decides the color of each individual pixel. So let's say this texture is 200 by 100, the vending machine texture, and I'll bring that up here. Machines. Yeah, 120 by 192. This will take 120 by 192. It'll calculate the individual color for all 23,040 pixels. It'll run that program 23,040 times per frame, this entire function. So when you think about the amount of processing power that goes into video cards these days, even on a smartphone, it's quite mind-boggling that it's running this 23,040 times a second, a frame, 60 frames a second. It's a lot. And this might happen for all kinds of objects on screen. A much longer program as well. Right, and so this is a very simple one that I've written here in the test. I took it from the, I took a program from the samples and I modified it. So basically, this takes the color of the texture that we have here, this texture. multiplies it by a brightness value, which we can pass into the shader as a uniform, and it also, sorry, that's it. It returns that as the color. Okay, so now back to the vertex shader. Oh yeah, actually, I've been using this vending machine as an example for a reason, and that's because if we go here to the vending machine entity, you'll see the code that I use to set up the shaders. And actually, Cocos2D.js supports WebGL, so in theory, you're supposed to be able to take your all this JavaScript code, chuck it on a web page, and include the Cocos2D.js HTML5 library, and voila, you have your game running inside of a browser. Unfortunately, the shader code for some reason differs. It's different. And in the example I saw, they had to have some compiler defines and basically write completely different separate shader code depending on whether they're running inside the browser or not. At the moment, I don't have any immediate plans to put this on a browser. I might decide that later on. So I just went ahead, I just wrote the code that runs on the mobile, right? Okay. So this shader, so basically you create a new GL program, and that loads the two files, the vertex shader and the pixel shader. You link the program. I think that's just a fancy way of saying that you compile it, and then I think linking is it'll put these two together. It'll connect the vertex shader to the pixel shader. In update uniforms, I think this goes through. Oh, well, like. This goes through and finds all the uniform variables. A uniform variable is a uniform variable is a variable that you're able to modify from inside your game code. And this bit is a little strange. You create this thing called a program state. This isn't that common with shaders, but it seems to be the way to do it inside Cocos2D.js. And then using that program state, you can adjust the uniform values. And finally, in order to apply the shader, well, okay. I am seriously lagging out here. What's the deal? Alright, I'm gonna fix this, and I'll be right back. Alright, where was I? So basically, I think I was going over this final piece of code here. You set the program state onto the sprite, and that's how you apply the shaded material. So what you're looking at here is the shader. The shader is actually running on the vending machine, and if we open that up here, you can see we got our shaders. So without modifying the shader at all, I can change this U brightness uniform variable. So let's get down here. Where was that? I think that was inside of vending machine. So I can change that here. Let's make it 0.5. It'll actually update instantly. There we go. Now all the vending machines are dark. If I set that to 0, they go black. And you see the alpha value hasn't been modified because what I'm doing here is I'm swizzling. I'm only changing. This is a 4-component vector, RGBA, but I'm only affecting the first 3, X, Y, Z. Essentially, RGBA and X, Y, Z, W are the same. You can also write this out like this, which is a little more readable actually, and it works the same. But I don't think you can mix. I don't think you can go XGB. That'll just, yeah, that actually crashed and produced all these errors. So make sure you don't do that. Okay, so we can modify that here, but we can also modify the uniform variable further down. Some kind of custom value. For instance, here I'm dividing the amount of visitors by 5. And the brightness is from 0 to 1. So if we have 5 visitors, it'll be 1. If we have more than 5, it'll be over 1. If we have less than 5, it'll be under 1. So see, 0 visitors, so it's completely dark. Oh, this one's got 1. You can see it's another one came in, it got a little brighter. This one's a little brighter now. This one is very bright because we got 4, oh, and there we go, we got 5 now. It's at full brightness. No, it even went over full brightness. It's almost glowing now. Come think of it, I think it looks better with a slightly brighter appearance. Okay, so yeah, so that was me demonstrating the uniform variable. Just going to comment this out for future reference. Come back here. Okay, so vertex shader. I just want to go over the vertex shader. It calculates the position. It calculates the color, which we don't really use. I'm actually going to go ahead and delete this because we don't need it. It calculates the texture coordinates. Now, texture coordinates are where the how the texture is displayed on here. So for instance, I could do this, texture coordinates times 2. See what happens. So this is the box of the vending machine, and because it looks like the texture wrap mode is clamp at the moment, so therefore you would expect to see 4 vending machines here with this modification, but we only see 1 because the texture mode is clamp. But also this might be more interesting. Okay, now you can only see a quarter of the vending machine. That's because this box here is the vending machine sprite. And this is the texture coord. So now they're going from 0 to 0.5. So they're only covering half the image. Okay, and if we set that to 1, then it's back to normal. Okay. For the position, we can go ahead and modify this a position, the X and the Y times 2. Oh, that did absolutely nothing. Why is that not changing? Perhaps it's at 0, so multiplying won't do anything. Let's try adding something. Oh, wow. So it's throwing an error. Lock the scroll. Oh, so this is read only. So let's store that in a temp. Okay, that did nothing. Let's try a bigger value then. There we go. Offset it. So that's what this does. Modifies the position of the vertices. Now we can do something kind of funky, like actually no, not really. We only have 4 vertices to play with. We could do something like times temp.y. Oh. Oh, this is breaking. Because I'm not putting a... Let me see, let's clear this. Oh no, it's not breaking. Okay. This value is just whack, so let's try and reduce that. Oh, there we go. Look, made it skew. Yeah, so you can do weird shit like that. Make sure you have a 0.0, otherwise GLSL will complain. HLSL doesn't care. Anyway, you can see messing around with the vertex shader, getting it to skew. Wow, look at that. Holy shit. It's intense. The skew. Alright, take that out. We're back to normal. Okay, so I've messed around with the vertex shader. I've showed you what's I've showed you briefly, very briefly, what's possible. Oh damn, I've actually got no idea how I would go about assigning another texture, CC texture 0. I think this is a job for the Sublime text. The Sublime text search, find in files. So this is CC texture 0. Now if I wanted another texture, I'm assuming it will be CC texture 1. Oh, okay. Alright. So it looks like this is prepended to all of the shaders. Now, how would we go about setting texture? Oh, okay, that finished. I thought it was still searching. Let's try search for this again. Alright. Doesn't look like anything useful is coming up here. Let's try this one again. Oh, okay. Oh, okay, we can search for uniform sampler 1. Alright, I decided to skip that part because it took me a while, but I finally came across an example showing how to pass in a second texture into a shader. So I'm going to go ahead and put that into the game, and I'll go over it as well. So I just copy pasted that from that sample. Don't need this. Oh, actually, no autocomplete. Okay. We're going to call this cloud texture. So as I described before, I have some clouds going over. So this is going to be the cloud texture, which I haven't actually created yet. So let's go ahead and call this res clouds. The reason I'm doing this is because most of the textures that have this clamp mode, and I'm going to set this to repeat, but you got to remember that a lot of video cards on cell phones, if you want the texture to repeat, it has to be a power of 2. Okay, now this is U underscore brightness. I'm going to call this S underscore cloud. S stands for sampler. Okay, and we can go ahead and let me just double check that here. This should be a sampler 2D. Okay, so that's a uniform sampler 2D. Just get the capitalization right, and that's going to be an S cloud. So I haven't actually made the cloud texture, so I'm going to go ahead and use GIMP for that. GIMP's a free. Alright, so long story short, my recording software, QuickTime Player, yeah, very professional recording software, decided to crash as I was saving the last segment. So I went through and I did this amazing video cast on how I got the cloud to show and all that, which you'll never see. But being the dedicated guy that I am, I decided to go back and redo it to the best of my ability. Now it's actually the next day, so I don't quite remember where I left off. I think I was about to draw this cloud texture. So as you can see, I've already drawn it, and basically that was just here's what I'll do. I'll make another layer, and I'll set this one to invisible. Yeah, I just went through with a brush. I made a cloud pattern, obviously slightly more wow, okay. Made a cloud pattern slightly more attention to detail than right now. Okay, more like this. Filled it in. I'm using a mouse, by the way. I do not use a Wacom tablet of any sort, and that's because, well, I just don't have one. But the second reason is that I'm making a pixel art game, and with pixel art, it's more like, you click this pixel, then you click this pixel. There's no need for that artistic freedom of range, freedom of motion, where you stroke. You're stroking all over the place. So I did that, and then I just adjusted the opacity layer. Yeah, just like that, and that gave us a cloud. Cool. So that's that. The shaders. Okay, so I'm gonna go over what I did to the actual JavaScript code first. And if you recall, just now I had the shader code inside the vending machine entity. I copy pasted that. I took it out. Sorry, I cut it, and I chucked it inside the lot view. And so now the lot view holds on to the shader here, and I set that shader not only on the vending machine but also on the background. And over here I'm doing some stuff. I'll cover this in a bit. I'm just going to comment this out. So what I'll do is I'll go to the shader, and I'm just going to gut out all the bits that I already did, and I'll do them again on camera so you can see what's going on exactly. Alright, so let's just double check it still works. No, it doesn't. The reason for that is because of this right here. Okay. Alright. So as you can see, nothing's happening, but the shader is applied to both the vending machine and the background, and I can prove that like so. And you see now everything's darker and transparent. Okay. So if we go back here, I forgot to cover this. I loaded the cloud texture, and I set its wrap mode to repeat. I think I went over that just now already. And then this is very important. You set the texture name as a uniform. So that's the sampler 2D. So we're going to go right here in the pixel shader, and we're going to set up a uniform sampler 2D. We're going to make that S cloud. Why S? Because I'm going to call it S because S stands for sampler. Oh, just an R. Just double check I spelled that right. Sampler 2D. Okay. So now we got that sampler. So we're going to go ahead and, you see nothing's changed because we're not using it. So let's go ahead and read from that. So cloud texture, all I do is I change the texture 0 to that, That still does nothing. But what if, for instance, I got this cloud texture and I multiplied it like so with the diffuse? And you'll see we have a big cloud and a little cloud. The big cloud is centered over the background, and the little cloud here is kind of hard to make out. That's the vending machine. Why is it like this? Because the cloud is essentially all black, and the only variance is in the alpha channel. And when you multiply, black is 0, and when you multiply by 0, you always get 0, so that's why you can't actually see anything. So another way to do this is to use the lerp function, which I went over in the last episode. Actually, if you're using HLSL or CG, it's called lerp, but in GLSL it's actually called mix. So we're going to go ahead and use mix. And how are we going to decide what value to use between 0 and 1? Well, that's easy. All we have to do is use the cloud textures alpha channel. RGB. I'm going to go ahead and actually do it like this, because I want to retain the diffuse textures alpha channel. I don't want to use the cloud textures alpha channel for anything. Alright, cool. Looks much better now. Now we have a cloud over the background and a cloud over the vending machine. But it still looks kind of weird, right? What if we mess around with the texture coordinates? What if for instance, I multiplied this by 2. Now I see we've got 4 clouds. And this repeats thanks to this setting that we have here, GL repeat clamp mode. Alright. But still, I mean, what the hell's going on here? We got 4 clouds in the back, 4 tiny clouds on the vending machine. They don't look coherent. They're not part of the same scene. And the way we're going to get around this is, instead of using texture coordinates that are dependent on the vertices, we're actually just going to generate texture coordinates using the current world position. Okay, and oh, I forgot to delete this. So basically we have this varying vtex coord 2. We're going to put that inside the vertex shader as well. And now in the vertex shader, we're actually going to go ahead and use the GL position as the second texture coord. And I've got some code. Oh no, I've got some code here which I already did. I'm just going to put that in here. So basically, we're just getting the x and y position of the vertices, and we're using that as the texture coordinate. And this is the world position. So depending on where the vending machine is placed in the scene, this position will vary. It's not a position that's local to the sprite itself. And right here, you'll see. Oh, ignore this last line. I'll come back to that. Right here, you'll see I did some multiplication, division by the screen height and the width. That's because the position goes from 450 to 0 to 450 and 800, 0 to 800. So if we want to center that correctly, we've got to do this. I actually don't know why the x is being divided by 800 and not the y. So when I figure that out, I'll let you guys know. But for now, it works. So we'll just go right here, text coord, Let's go ahead and use that for the cloud texture. Voila! You can see that the cloud goes from the background and it's on the vending machine. Alright, almost done. Now the very final part is we want the clouds to scroll. We want them to move. So what I'm going to do is I'm going to introduce this uniform variable. And the uniform variable, just to go over it again, is something that you can modify inside your game code, and you can pass that value down to the shader. And what we're going to do with that is we're going to just increment the texture coords based on what that value is. That value, we're going to calculate that value right here. So I've got this number, cloud counter, set it to 0, and every frame inside the lot view, and right here I'm updating the lot view every frame. We take the delta time. That's the time that's elapsed since the last frame, and we increment our number, our cloud counter, and we pass that in as the uniform floating point value. And look right here, I divided by 20 because when I had it like this, it was just going crazy. There's a typhoon. So yeah, so there we go. This is essentially where I ended it last time, and I think I managed to cover that very quickly. I don't know how long it's been since I started recording. And yes, the clouds don't touch the people right now, though I could fix that very easily. I think all I have to do is go here and do that. Oh. bit of cheating here because I'm not storing the program state anywhere, so I'm just going to grab it from the background and check it on the people. And we should actually be able to see the cloud affects the people now. I'm quite happy with that, with how that looks. Now I know you're all thinking, what's the point of this? Why did you go through all this trouble when all you have at the moment is essentially a transparent texture that's overlaid on top of everything? Why do you need to do this program state, whatever? Why can't the cloud just be a sprite? And yeah, it totally could be, but the reason I'm doing this is so that, as I said earlier, I want the cloud to deform with the geometry of the scene, which at the moment it's not doing that. So I will get around to that, and you will be able to see exactly what I mean when I say that. Alright, so let's go to, I think this is probably a good, yeah, this is a good lot for showing exactly what I mean. Okay. Next step, man. I feel like this is going to be tough. Okay, I'm going to make two versions of the texture. sorry, not texture, of the shader, and that's gonna be because only some of the objects on the scene will actually want to deform it. So if it's on a person, he might just want to just take the cloud as is. But if it's on the vending machine might say, oh, actually, I don't want the cloud to float over my side like this. I want it to like affect me in a different manner. Okay, and you know what? This is a crazy idea that I had. So I can't guarantee that it'll actually look good or even work, because I don't know who else has done this before. Alright, so let's see, cloud displacement. It's too long. I don't like it. I'm just gonna call this cloud D, and I'm gonna call this one cloud S. S stands for simple, or a single, or whatever. Okay. So I'm gonna keep these ones as is. I gotta do this. Open up text editor. I'm going to keep these two as is. These ones I'm going to modify so that they actually take not 2 but 3 textures. Man, that's really going to overwhelm some smartphones if I'm not too careful. Alright. Let's see right here. Okay, so here's the deal. Here's the deal. What am I doing next? Basically, let's say we have a vending machine like this. The top of the vending machine, the displacement value is 0 because it's facing the same direction as the ground. But the side and the front are going to have different displacement values. For instance, the front is going to this entire front area is in the same position as this tiny is in the same if we're looking at the if we're looking at the scene from a bird's eye view, top down, you're not going to see the sides. You're only going to see the top. So this entire position from the bird's eye view is actually just this tiny line here. And this entire section here is just this tiny line here. So I'm gonna just jump into the GIMP, and I'm gonna load. How do I do this? I think if I drag it like so. Okay. So I'm gonna copy that. I'm gonna call this vending one D. Okay, this is a displacement map. I'm gonna zoom in a bit. Oh no. And I'm gonna make another layer. Actually, I'll duplicate. Okay, so the top is gonna be Do I want 0 or 1? Because I was thinking I'd use 0 as to indicate that. What was I going to use it to indicate? That I don't want clouds? I don't see why I would want that. I'm not sure. Let's go with 0. So the top is 0. Now we're only using the red channel. So this is going to be a black and white, or a red and black, black and red texture. So we're going to go foreground to background. This is full red, RGB. Foreground to background. I'm going to select this right here, and essentially I'm going to do that. Now you might be thinking, what's going on here? Basically, actually, this is, what is this? 1, 2, 3, 4, 5, 6, 7. This is 148. Okay, so actually this is going to be 100. Alright, so lo and behold, QuickTime decided to crash for a third time on me. And every time it crashes, I manage to recover like 30% of the recording, and 70% is just missing. So I'm incrementally recording this episode 30% at a time, and it's like every time that 30% shrinks, because it's like 30% of the remaining time. So if I kept using QuickTime, if you asked a mathematician, he might say that I will never finish the episode. It will take me infinity years. Okay, that was a lame joke. So I've switched over to this OBS thing, which people actually use for like streaming Twitch games and all that. So I figured it's a lot more durable and it's a lot more of a professional solution for this kind of thing. And maybe I can even use this program to do some live streaming one day when I have an actual fan base. Right, so what also happened is that because QuickTime Player crashed 3 times, I had to basically delete all the work that I did or copy it and start from scratch every time, because I wanted you guys to see me making it incrementally. Unfortunately, after it crashed 3 times, I was a bit down, and I got fed up, and I left this project for a few weeks. So now that I'm back, I'm not gonna do it. I'm not gonna code it from scratch. I'm just gonna go over. So you probably just saw the last part where I was drawing this. So I'm just gonna fill you guys in on what I did after the deleted scenes. So if I recall correctly, I was creating gradient here, and I was explaining that every increment of the red value equals 1 pixel distance. So I went ahead and did that for the vending machine, and you should be able to see the vending machine itself. This is the vending machine here, and the file, I saved it as vending1d, so I'll just put the letter D to indicate that this file is the displacement map for the above file. I also went ahead and did the same for this alleyway. So this alleyway here, you can see that has this the side of the pavement here, and another part is these houses or buildings. So if I go down, It's hard to make out, but this part is very dark, is practically black, and this part is a very, very, very slightly lighter shade of red. And then here you can see the just like the vending machine, because it's a straight up wall, it's a gradient. So I'm not sure how well I explained it in the last section, but the idea is to offset the texture read from the cloud texture based on this value right here. Okay, and here we have the shader, the vertex shader, and I think it's practically the same as what I showed you before. It just moves the second texture coordinate along, and it grabs that, it generates that straight from the vertex position. And oh yeah, I put this uniform, that's new. This is the view size, and if I go into lot view, should be able to see the view size right here. It's the size times 3. It's the content size. So I figured out why it was getting stretched, because it's not relevant to the, it's not related to the size of the screen, it's related to the size of this lot view right here. But anyway, enough about that. This is the juicy part, the cloud shader, the cloud displacement shader, pixel shader. Okay. So the first thing we get is we read from the displacement texture. And that uses the exact same texture coordinates as the diffuse texture. This is all this is a little verbose. I can actually just try it. I can just do that. But the shader compiler is smart enough to know that those two are the same things, and it'll optimize it down to basically just this. Oh, I don't even need the swizzle. Yeah, that should work just fine. Right, so next, so we get the displacement texture, we get the coordinates for the cloud, and then we get the red channel, this, sorry, wrong screen, this right here, the red channel, and multiply that by 255 because this is a RGB going from 0 to 255, but inside the shader the values go from 0 to 1 as a floating point value. So we're just recreating what we have here. And then we divide by the view size and the y. And you'll notice I'm multiplying by 3 here. That's because we scale up the sprite by 3. So I'm getting the real width and height. Otherwise, if I just get the content size, it'll give the value it'll give me is only a third of the real size. So going back to the shader, so once we offset the y value, we go and we use that to read from the cloud texture. And so read from the cloud texture right there. And then after we've done that, we read from the diffuse texture. And that's just the, hey, where did I put that? That's just the that's just this. This is the diffuse, and this is the offset. And the cloud texture itself is, this is it right here. Okay, and then once that's done, I use this mix function. That's the same as lerp. So if you know what yeah, okay. I explained lerp a few times already, maybe 3 times on this series. Mix is essentially lerp. It's just another name. It's the name that mix is called in GLSL. Sorry, it's the name for lerp inside GLSL. But if you were to code HLSL, the direct 3D shaders, it would still be called lerp. So I remember back in the day when I was coding shaders for both platforms, when I'm porting a shader from HLSL to GLSL, I have to remember to change lerp to mix. But only on ATI graphics cards, because NVIDIA graphics cards would get they would use the CG compiler. They would convert the GLSL files to CG and then compile it. And CG is based on HLSL. So essentially, any HLSL code would work inside OpenGL on NVIDIA cards, because they were actually just converting all the GLSL into a subset of HLSL. But then the problem was that if you're developing on NVIDIA card and you accidentally write float 4 instead of vec4, or you write texture 2D or text 2D or whatever it is in GLSL in HLSL, it would still work, but then you'd give it to your friend with the ATI card and it would crash. So yeah, that's something to watch out for. Probably not so important these days, because most people are making mobile games and they only have to worry about GLSL. Now, okay, so back to that. So we mix it together based on the cloud textures alpha, and then we set the output color, and that's it. So how does it look like? I've got it right here. So basically, you can see the cloud passing. As it passes over the vending machine, it'll go up the wall, it'll go up the side, and it looks cool as it's coming off. And you can even see here, you can see that as the cloud is coming off the pavement, you can see as it's coming onto the pavement, it's a very subtle effect, and as it's coming off, you can see that pavement is behaving as a 3D object would. And same with the wall. Though the wall is showing some artifacts along here, it might be that my displacement texture needs some tweaking, or perhaps the shader needs tweaking. Yeah, right here. This should be happening a bit lower, but it's not a big deal. Now this game is going to have quite a bit of effects on top of this cloud thing, which you're only going to see on cloudy days. I mean, we're not always going to have clouds, but on top of that, I'm going to have things like rain. I'm not sure what else, and I'm going through this quite a bit of detail, and I might put up some of the code on the blog as well. So keep your eyes on the blog. I haven't updated it much recently, but once I get this episode up, after a couple of days, I'll put up some code from there. So maybe you can recreate this effect in your own isometric games or 2D games. Yep. Yeah, I think that's it for today. Thanks for joining me. I'm finally getting this episode out after so long and so much heartache with with QuickTime crashing on me like 3 or 4 times. So, yep, that's me. And